All right, so this is your bright green piece of paper, and this is what we'll put on page 129. And then the yellow paper, that's going to go in there as well. Like I said, we're going to go back and forth, so this will go on 130. And because these strategies work for today and tomorrow. The difference is tomorrow you'll have a calculator, today you do not. So like I said, we're going to go back and forth, and we'll start with the strategy, then we'll go do an example, and then come back. So there's all these different lists of things, which seems like overwhelming, but it's really not that big of a deal. It just kind of breaks it down for you. Here we're trying to solve for x, but we have 3 times the cosine of x minus 1 equals 2. So we're just going to isolate the single trig ratio, which means that I need to add 1 to both sides. So I get 3 times the cosine of x equals 3. So cosine of x equals 1, right? So if the cosine of x equals 1, then x equals the cosine inverse of 1. Right? Isn't that how that works? Take the cosine inverse of both sides. And then all of these today, and most of the time when you're answering these, it will tell you that you are answering them between 0 and 2 pi. Okay. And you can think about these a couple of different ways. You can think about it on your unit circle. Okay, so you got your unit circle here. You know, your cosine is your x value. So when x is 1, you're right here, right? So this would be what value? 0. So how many answers would you have here? If this is just 1. You can also think about it as your parent function. Parent function of cosine is going to look like this, right? On one period, from 0 to 2 pi, how many times is that function at 1? Twice, right? Here and here. So what's my answer besides 0? 2 pi. So your answer to this would be 0 and 2 pi. Does that make sense? And again, you can think about it on either one, whatever makes the most sense to you. For the values that aren't your quadrantal values, thinking about it on the unit circle is sometimes more helpful than trying to think about what goes in that graph. But your zeros and your ones, thinking about the parent function can be very, very helpful. Okay, so let's go to here and let's look at this. So we're going to isolate the trig function here, which means I've got 5 cosine x equals 3 cosine x plus the square root of 3. So I'm going to subtract 3 cosine x from both sides. So this is going to give me what on the left-hand side? 2 cosine x. Okay. 2 cosine x equals square root of 3. So the cosine of x equals square root of 3 over 2. So to make this look exactly like what we did before, x is equal to the cosine inverse of the square root of 3 over 2. Now, the difference between this is we're actually, this and what we just did is we are actually solving equations, and we are told, oh, I didn't put that on here. We are solving on the interval. Should have put that on here. Solve for x on the interval 0 to 2 pi. So we had restricted the domain when we were doing inverses to make it a function, right? So for cosine, we were only going from 0 to pi, but we're actually answering these from 0 to 2 pi, so that's going to change maybe how many answers we have. We could have 1 answer. We could have up to like 5 or 6 answers, depending on what's going on, okay? Now in this one in particular, so I need the cosine inverse of the square root of 3 over 2. You can look at it a couple of different ways. First of all, cosine inverse, or cosine, is positive in which quadrants? 1 and 4. Okay, so we're looking at quadrants 1 and 4, right? And then you want to think about the way you look at your reference angles. So first of all, what's your reference angle for square root of 3 over 2? Pi 6th, right? Square root of 3 over 2, so it's pi 6th. So I know that this is pi 6th. Do what? Why are you lost? Okay. Where did I lose you? No, you're good. You're not lost. He just won't shut up. Is that the problem? Okay. Leave him alone. Let him think. Okay. once you get your reference angle, then you can think about any reference angle that you get. This is just alpha, or your reference angle, right? In quadrant 2, this is going to be pi minus your reference angle, whatever it is, right? And then this is going to be pi plus your reference angle, and then this is 2 pi minus your reference angle. Remember when we looked at it like that finally? So if we just think about pi sixths and get all of our angles here, this is pi sixths, right? Pi minus pi sixths is 5 pi sixths. Oops. Dang it. What goes here? 7 pi sixths and 11 pi sixths. So this is where they come from, or you can just know them, right? But we only want them for quadrant 1 and quadrant 4. So the solution to this is going to be pi sixths and what? 11 pi sixths. We get 2 answers here. Okay, everybody good with that? Any questions? That definitely you want to think unit circle and not graph, because that would just be weird. But okay, we good? And I'm not going to make you write this necessarily every single time. You can stop here and just know what x is, and that's okay. I just want to make sure that you understand what it is that we're doing. Okay, we're actually, when x is the, or I'm sorry, when the angle is the variable, you're getting an angle as your answer, so it's an inverse, just like what we've been doing. Okay, but it is okay to stop here and just get your answer and kind of skip writing that. If it makes you feel better, like you need to write it so you know you're going in the right direction or whatever, that's fine too. It's just not always a necessity. Okay, so now we're going to go back to the yellow sheet. Remember I told you we're going to kind of go back and forth here. And we're going to look at a couple of factoring things. First one is just factoring out a GCF. All right, this is a factoring problem, so what's your GCF here? Cosine of x, right? So if I factor out a cosine x, that's going to leave me with 3 cosine x minus 2 equals 0. So just like when you factor a quadratic, which that's what that was anyway, you get at least 2 answers. I've got to set both of these equal to 0, right? So I'm going to set cosine of x equal to 0. And I'm going to set 3 cosine of x minus 2 equal to 0. Everybody with me on that? So this is going to get me an answer. And then when I solve this, I'm going to add 2 over here and then divide by 3. So that would mean that the cosine of x is equal to 2/3. And there's the other one where I would get an answer. Now, is the cosine of x equals 2/3? Is that a value that you would just know? No. Okay. This one, yes, you could get an answer here. This one right here, this is going to be a calculator thing, and we'll get to that tomorrow, but that's how you would solve it. You're not expected to just know that. You would use the calculator, but we're going to solve them the same way today and get answers that we can find without a calculator. Okay, we good? All right, so let's go back and do another example. All righty, let's see. So in order to do this one here, I need to, oh, I'm on a different one. Before I can factor anything out, what do I need to do? What do you always have to do before you factor? Set it equal to 0. Okay, good. So we need to set it equal to 0, right? And you could move either one. I'm going to move this over here to the left. So this is going to give me 2 sine of x cosine of x minus the square root of 3 times the sine of x equals 0. Okay, so now I've got it set equal to 0. So now, do I have a GCF? Yes, it's what? Sine of x. So sine x times 2 cosine x minus what? Square root of 3 equals 0. So now that I have it factored, I can set these two things equal to 0. I can set sine of x equal to 0. And 2 cosine x minus square root of 3 equal to 0. So I'm good over here, and I can go find some solutions. But then over here, I need to move the square root of 3 over and then divide by 2. So the cosine of x is equal to the square root of 3 over 2. So these are the two things that I'm going to use to get my two solutions. Right? For the sine of x equal to 0, how many answers is that going to give me? 2. When is sine 0? Okay, so this is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Okay, so when is sine 0? It's 0 and pi. So when I look at it like this for sine, how many times is sine 0? 3 times. Be very careful, okay? This is one of those very, very common mistakes. If all you're thinking about is the unit circle, that's okay, but you have to understand that this is 0, this is pi, and this is 2 pi, because we are going from 0 to 2 pi. It is possible that the interval that you're given could be an open interval, so maybe you only have 2, so you have to pay attention to your interval, okay? Because honestly, there's an infinite amount of answers, right? So good thing they only give us from 0 to 2 pi, but there are 3 things that I'm getting there. I'm getting 0, pi, and then 2 pi. I get 3 answers from this right here, okay? Does that make sense to you? Then I have to look at this for my cosine. So for cosine, when I'm looking at this, which quadrants is cosine positive? First and fourth, right? What's your reference angle for square root of 3 over 2? Pi 6. Okay, it's showing up again. So I know pi 6 is one of them. What's the other answer? 11 pi 6, because it's the one in the fourth quadrant. And so there are your 5 answers. And that's how you can get 5 from just having 2 simple things. No. Right. Okay, everybody okay on that? Any questions at all? Okay, so I think I'm going to go back. Yeah. I know it's back and forth and back and forth. Okay, I feel like this doesn't go. All right, so we're going to do this one. I'm not sure that it's on that yellow sheet. I tried to make sure they were in order, but I think that I might have missed one somewhere. Oh, I know what it is. We're going to go and look at the difference of 2 squares. So we are going to go back because you can do that one 2 different ways. Okay, so we've got here, one thing that you need to be able to recognize is in your factoring, because this is still a factoring thing, but the difference of 2 squares. Is that a pretty easy thing to factor? Using the, yes, okay. So this is going to give me 2 tangent of x plus 3 and 2 tangent x minus 3, right? So that means that I'm going to get 2 tangent x plus 3 equals 0, and 2 tangent x minus 3 equals 0. So that would give me that the tangent of x is equal to negative 3/2, and tangent x is equal to positive 3/2. Another way to solve that is square root. Now, can I just take the square root of both sides and be done with it? By the way, it looks right there. I just take the square root of both sides. Does that work that way? No. But can I get the tangent squared x by itself? So I could get 4 tangent squared x equals 9. And then tangent squared x equals 9/4. Now can I take the square root of both sides? And when I do that, when you take a square root, how many answers do you get? 2. You may not always need both of them, but you get 2 answers. So what you get here is that the tangent of x is equal to plus or minus 3/2, which is what you got over here as well, just as 2 separate things. So really working it either way works just fine. Okay? Everybody okay with that? Any questions? Yes, ma'am. It's the square root. We take the square root here. It's the square root of 9/4. And so when I take the square root of 9/4, yeah, because I actually take the square root of both right here. That's a good question. I kind of skipped that step. But the square root of 9/4 is the 3/2. Okay. You still have two answers there. We good? Okay. And then that's not the final answer to it, but that's how you would solve it. I know there's not a ton of room to work all those problems. So this one we'll solve by taking the square root. So I'm going to move this over. I'm going to get 3 tangent squared x equals what? 1. And then tangent squared x equals 1/3. Goodness. All right. And then tangent of x is equal to plus or minus the square root of 1/3. Okay. Now, square root of 1/3 is actually plus or minus 1 over the square root of 3. Now, what's wrong with that? Can't have a square in the denominator. So you either know what it is, okay, which really after a while you should just know what it is because it's the same steps every single time. But this gives you plus or minus the square root of 3 over 3. Okay, if the square root's in the denominator, it's just square root of 3 over 3. So that's what we have. This is tangent of x, since we're there. So we need to solve that, right? When you have your unit circle, okay, I have positive and negative for tangent, so that takes up all 4 quadrants. It's all 4 of them, right? Not just the positive, not just the negative, but it's plus or minus. Square root of 3 over 3, what's your reference angle? Pi 6, right? And we already have them all figured out up at the top anyway, so when we get our answers here, it is pi 6, and it's all of them. It's 5 pi 6, 7 pi 6, and 11 pi 6. And our notes have a lot of pi 6 answers on them, and that's okay. We all good? Any questions at all at this point? Okay. All right, on the inside. So now we're going to solve by factoring with the Pythagorean identity. So let's go back to this one. And I guess I'm going to come back to that in just a second. We're going to skip down here. I didn't do great on my ordering here. All right, so we're going to substitute with the Pythagorean identity. When you've got sine and cosine in something, you need to figure out how to make it not have both unless you can factor out a GCF like we did up there. There's no GCF to factor out here, but I can substitute cosine squared x with what? What's your Pythagorean identity that I could substitute in here? Isn't the Pythagorean identity? Yeah, this is cosine squared x plus sine squared x equals 1, right? That's your Pythagorean identity. So this would be 1 minus, yes. So this would be 3 times 1 minus sine squared x equals sine x minus 1. Okay. And then you would distribute and you could just work it from there, but it gets everything in sine. Does that make sense? I'm not going to finish that out because that's what the next example is anyway. All right. And just like anything else that you ever solve, you have to kind of look at it and decide what you want to do. Now, this has a sine squared x and a cosine squared x, so you could replace either one. But if I replaced this with 1 minus cosine squared x, I don't know that that would help me much since that's a sine in there, right? Wouldn't it make more sense to replace this one? You agree with that? So you kind of have to make that decision before you start. So I'm going to take sine squared x minus sine x plus 1 equals, and then instead of this, it's going to be 1 minus sine squared x. That's why we need those identities to help us change this into something that we can actually solve. All right? So now I'm going to, looks like something that I'm probably going to have to factor. So I'm going to move my sine squared x over to the left. That's going to give me 2 sine squared x minus sine x. Then what? Equals 0. Okay, because you subtract 1 from both sides and you got your equals 0. So now, although it's factoring, it's not as bad of a factoring as it initially kind of looked. I can just factor out a GCF here, right? So this gives me the sine x times 2 sine x minus 1 equals 0. So now sine x equals 0, and 2 sine x minus 1 equals 0. So we're good here. This needs to become sine x equals 1/2. Okay, so those are the two things I'm looking at to solve. Here's my sine function. How many times does sine equal 0? 3. Okay, so my 3 answers for that part are 0, pi, and 2 pi. How many times, now you can look at, this graph won't necessarily give you the answer to it, but how many times would sine equal 1/2? Wouldn't 1/2 be like right here? So I should get 2 answers from that, positive 1/2, at least tells you that. Again, I wouldn't guess my answer off of this or anything, but there's 2 answers there. So what is your reference angle for 1/2? Pi 6th again, yeah. Okay, so it's pi 6th, and then I need my other one, and sine is positive in quadrant 1 and what? Second. Okay, good. So that would be 5 pi 6th, yes. And there are your answers. Okay. Don't try to confuse me, because that's right? Okay. I know, just seeing if I was paying attention. Yes, it's because I'm looking at where it's positive. Does that make sense? And it's, yeah, it's different. It's a different restriction than the homework that you just turned in. Yeah. All right, are we all good? Questions? No? You good? Sure. Okay. All right. Let's see. So this, we've already done this example. I feel like I left one off of here. What the heck? Maybe it's on the back. We already did this example for factoring with difference of 2 squares. Could I do the square root thing here? Yes, but let's just go ahead and factor it with difference of 2 squares. It's going to look like this. Sometimes I regret putting my parentheses there first because then I have too much to write. But so I take the square root of the first one, 2 cosine of x, let's see, plus 1, and 2 cosine x minus 1. So really easy factoring. Then 2 cosine x plus 1 equals 0. 2 cosine x minus 1 equals 0. So I get that the cosine x is equal to negative 1/2. And cosine x equals 1/2. Which if I'd have done the square root thing, I'd have it all in one. It'd be plus or minus. It's the same thing. So since it is plus and minus, it's going to be in all 4 quadrants. What's your reference angle for cosine of x being 1/2? Pi thirds, right? Okay, this is your 1/2, is your pi thirds. Okay, so this means that I'm going to have pi thirds. Then what do I get in the second quadrant? 2 pi thirds. 3 pi thirds is pi, so then that gives me 4 pi thirds, right? And then 5 pi thirds, because, oops, then 6 pi thirds is 2 pi. So there are my 4 answers there. Okay, we good? Got to know your unit circle, and that's why I told you, and I know I didn't because things have been too insane that I haven't given you those little quizzes that probably should have because it would have forced you to know. You've got to know those things. You've got to know what's going on in the unit circle. Okay? Are we all agree with this? Any questions? All right. Double check that I was right on that. Yes. Make me second guess myself sometimes. All right. Next one, double angle substitution, and I think we'll go back to, because we love double angles, right? Yeah, sure. Okay, so your substitution with the double and half angle identities. Now, we did not do half angles, so we're not going to worry about that, but we're going to look at the double angle. And for cosine of 2x, you have 3 choices, okay? So the first one is the cosine squared minus sine squared, and then cosine squared minus 1, or 1 minus sine squared, right? In this particular case, if I am going to replace this, because I want to replace my double angle, what would make the most sense to use? The one with just the sine? Would you agree with that? Like you kind of decide, I don't want to introduce, like if I'm trying to get rid of this, if I have sine and cosine in there, if I can just get down to one trig function, that's great. So instead of the cosine of 2x, then I'm going to make that 1 minus sine squared x equals 3 times 1 minus sine x, and then just go from there. Okay. Oh, 2. I'm sorry, 1 minus 2. Dang it. It's 1 minus 2 sine squared x. And we're not going to finish that one, but that's just the substitution you would do. Then you could distribute it and do your thing or whatever. We'll do the actual example on the notes, but that's the substitution that could help you there. All right, so here, this is sine of 2x. It's not cosine of 2x. Now, do you have a bunch of options for this one? No, and this one really isn't that bad. This is just 2 sine x cosine x minus sine x equals 0. Okay, so that looks way more doable, right? What would I do here? Factor out. Okay, so I'm going to factor out the sine x. That leaves me with 2 cosine x minus 1 equals 0. So now sine x equals 0 and 2 cosine x minus 1 equals 0. So I'm good here. This needs to become cosine x equals 1/2. So how many times is sine of x 0? 3. 3 times. Don't mess that up. So that's going to give me 0, pi, and 2 pi. And then cosine being 1/2, isn't this pretty much exactly what we just did? I think we end up kind of with the same thing. But cosine 1/2, but this is only positive, so what quadrants are, all students take calculus, 1 and 4. So I do want the pi thirds, and then what? 5 pi thirds, good. You get 5 answers there. Okay. Any questions about that? Not so bad, right? We're just kind of putting it all together. All right. All right, so division. And we'll go back to this, because it's said a little bit different over here, but you're kind of doing division. One of the things that we'll look at, actually we'll look at what you can't do in just a minute. So what this says is create a tangent problem from sine and cosine. All right, so I can't just replace, like if that was a cosine squared or a sine squared, I'd be able to use a Pythagorean identity and change it so it's all just one function. There's really not a GCF to factor out here, but I can make this into a tangent problem, right? What do I have to divide by to get tangent in here? Cosine, right? So if I divide both sides by cosine, now, sometimes division is illegal, and we'll look at when it's illegal. But here, even though we are canceling something out, we're not canceling something out on both sides. Okay, and that's where the difference comes in. Yes, these do cancel out, but we're not truly losing it. It's still over here. It's just going to morph into a tangent. Okay, so on the left-hand side, I'm left with 3 equals, and then this is going to become 2 times the tangent of x, and then I can go from there to solve it. Okay, does that make sense? We're good on that? And this, because when you solve this one, you'll get that the tangent of x is equal to 2/3. No, 3/2. Oh, good God. Okay. Sorry. 3/2. This is another one which it would be a calculator problem at that point. You're not expected to just know that. All right. So back over here. Sine x equals cosine x. So I can't, there's nothing to factor out or anything else, so I'm going to divide both sides by the cosine of x. So although these do cancel out over here, I'm really just doing that to move the cosine over. So this gives me sine over cosine is going to give me tangent of x equals what? 1, not 0. Thank you for not saying 0. Okay, it's 1. So how many times does the tangent of x equal 1? When is tangent positive? 1 and 3, right? First and third. And when is tangent 1? What's your reference angle? Pi fourths. So this is pi fourths. What would that be in the fourth quadrant? 5 pi fourths. So those are my two answers there. 5/4 and 5 pi 4. Okay. Now, here, legal to divide. Here, not legal to divide. Okay? Because here's what happens over here. If I do that, sine squared x equals sine of x. If I divide both sides by the sine of x, it looks very similar to what we did up there, right? But this cancels out, and this would cancel out, so you would get sine of x equals 1. And although that is a true statement, I lost a factor, right? That's just like if you had something that was 2x squared equals 3x. Are you allowed to divide both sides by x? You're not, because you lose a factor, right? So just like this was a big fat no-no, like you sometimes get one of the answers, you get half the answer. This is not okay either, because here it cancels out on both sides, where up there we really just moved it. You see the difference? So be careful here. Here, I can move things over in factors. So if I subtract sine x from both sides, I'm going to get sine squared x minus sine x equals 0. Then I can factor, right? So then this is going to give me sine x times sine x minus 1 equals 0. That means that sine x equals 0. Sine x minus 1 equals 0. So we're good there. And sine x equals 1. All right. How many times does sine of x equal 0? 3 times. So this is going to give me 0, pi, and 2 pi. Okay. How many times does sine of x equal 1? Once. And when is that? Pi halves. And see how you can see it on the graph, too. There's only once where the graph actually hits 1. Okay? We all good? Yes? All right. Is this the last one? Dang it, I totally left a problem off somewhere. Okay, I got to go find where that is. I'm not even sure what I just did. Okay. Because there's another example I want to do with you. All right, I'm sorry. Reciprocal substitution. Let's go back over here. So rewrite in reciprocal form. Now there's a couple of different ways to do this. Okay, I'm going to show you the actual, like, I don't know, both of them are actual mathematical ways. I shouldn't say it that way. But secant of x is equal to 1 over what? Cosine. So this would be 1 over cosine of x, which would equal 5. Right? So then if you actually solved this, then that would, if like you put that over 1 and you cross multiply, you'd get 5 times the cosine of x equals 1. So cosine of x equals 1/5. Okay? So that's one way to do it. But if this is the reciprocal, then isn't just the cosine of x going to be the reciprocal of this number right here? So you can just go straight to, this would be the cosine of x equals 1/5. Because it's the same thing happens every time. You don't have to go through the mathematical process of it. Okay, we good? Just got to recognize your... All right, so secant of x, we're not even going to have time for a quiz today. Secant x plus 2 equals 0. All right, so what I would do, I would not go ahead, I wouldn't change it right now. I'd go ahead and move this over and say that the secant of x is equal to -2. So that means that, what's the reciprocal of secant? Cosine. So the cosine of x is equal to what? -1/2. Good. All right, so which quadrants is cosine negative? 2 and 3, right? What is your reference angle for cosine 1/2? Pi thirds, right? Okay, so I don't even want pi thirds. That's what goes here, but I don't want that one. Instead, I want 2 pi thirds and what? 4 pi thirds. Good. And so I guess the example that I will do is go back. If we'll go back, it's on your yellow sheet, and it's fine. We'll just do it there. It's one of them that I skipped because I thought I was coming back to it, but apparently I didn't. So well, look at the factor a trinomial into two binomials. Okay. So this is one that I cannot factor out of GCF, but we're going to literally factor it. But what I would suggest that you do here is something that I mentioned once, and that was it. But U-Substitution, do you remember me even talking about that? Okay, it was when we were trying to factor the weird things like the logs or the exponentials or something that we were factoring, which was a weird kind of problem. But so that you don't get mixed up in there's sine stuff in there and you're doing weird things, one thing that you do in calculus is something called U-Substitution, so that you can do the easy algebra on weird looking stuff. So I'm going to substitute, that's why it's called U-Substitution. I'm going to say U, I'm not sure why they use U. I think I asked, but I don't remember what the answer was. And I'm going to say U is equal to sine of x. So I'm going to change that to, change this right here to be 2u squared minus u minus 1 equals 0. Does that make sense? I just substituted u in for sine. So now I need to factor that. That is a little less intimidating than the other. So now when I factor this, okay, I know that this would have to, one of them would have to be 2u and u, and these both have to be 1 to get that negative 1. But one's positive, one's negative, and you got to decide you want the bigger one to be negative. So when you multiply those two, that means this one will be minus, and this one will be plus. Does that make sense? Now, you do not have to substitute if you don't want to, but I think you're less likely to do weird things or freak out because it's trig, right? So now that I have it factored, I'm going to substitute it back in and say, all right, instead of u, what I really have is 2 times the sine x plus 1 times sine x minus 1 equals 0. Again, you don't have to substitute, but it does make things a little bit nicer sometimes. So now that I have that, I've got 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. So that means that sine x is going to equal negative 1/2, and sine x equals 1. And then we'll just go ahead and finish this one off. Okay. So negative 1/2. I'm using negative and positive. Well, when is sine negative? 3 and 4. Okay. What is your reference angle for a negative 1/2? I'm sorry, for 1/2 for sine. Pi 6. Okay, but I only want pi 6 in these two. So this is pi 6. This is 5 pi 6. What's this? 7 pi 6, and then 11 pi 6. Okay. But then I also need to know when sine is positive. That's these two, right? But it's a 1 anyway, so it kind of doesn't matter. When does sine equal 1? Pi over 2. Okay. Any questions at all? Okay. And one thing I got to learn from Miss Rice, I don't know how she gives quizzes all the time. I don't ever have time for quizzes. I must talk too much. I guess that's it. I need to stop running my mouth.